Hi everyone! Today's lesson, you are going to generate simple equivalent fractions by using visual fraction models and the number line. In yesterday's lesson, we recognized that equivalent fractions have the same size but not necessarily the same shape. Here are some examples that we looked at. These examples are all equivalent because they all show 4/8. So 4/8, oops, let me get my pen. These three fractions all show 4/8. Even though they are all different shapes, they are all still showing 4/8. Model 1 and Model 2 show 1/4. The size of the units and the size of the whole didn't change. That means 1/4 and 1/4 are what we call equivalent fractions, even though the shapes of our wholes are different. We're going to go ahead and take a look at equivalent fractions. Equivalent fractions are different fractions that name the same amount. So let's go ahead and take a look at some of those. In this example, I see three different fractions. I see 1/3, 2/6, 4/12. Again, they are all different. But when I look at the visual model, the tape diagram that was drawn, I see 1/3, 2/6, and 4/12. The amount that's shaded, which is all right here, they all take up the same amount. They are all equal. Different fractions, but they all name the same amount. In the second example, I see two circles. The first circle cut up into thirds, and the second circle cut up into sixths. Even though they are different fractions, the amount the shaded area takes up is the same. Look at the amount of the shaded area here compared to when it's broken up into sixths. We did a similar problem like this yesterday where we cut the thirds in half to make sixths. Our whole did not change. It just has more equal parts. The shaded area stays the same, so the fractions are equivalent. So again, I can show you that one more time by cutting it up into thirds and shading in 2/3. Now if I were to cut my thirds up in half, I now have 6 pieces. 1, 2, 3, 4, 5, 6. I'm just taking my thirds and I'm cutting them into halves to make another equivalent fraction. I didn't change my shaded area at all. So 2/3 equals 4/6. Different fractions, but they name the same amount. Let's look at a different model. These three wholes are the same. I'm going to write the shaded fraction as I name it. So this fraction, the first one, shows 1/3. The second picture shows 2/6 shaded, and the third picture shows 3 out of 9 shaded. Are these fractions equivalent? I'm going to place these fractions on a number line to prove my answer. So I'm going to fix my number line by making arrows on the end of them. And I'm going to take a look at my first one, and since it's broken up into thirds, I'm going to break my number line up into thirds. So 0, 1, 2, 3. I know this is 1/3, 2/3, 3/3. That's my first one, and 1/3 goes right here, so that's where I'm going to plot it. My second My second whole is broken up into sixths, so I'm going to break my second number line up into sixths. So 0, 1, 2, 3, 4, 5, 6. 1 6, 2 6, 3 6, 4 6, 5 6, and 1 whole is 6 6. Here's where 2 6 goes. Right there. My third whole is broken up into ninths, so I'm going to break my third number line up into ninths. So I know this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know this is 1 ninth, 2 ninths, 3 ninths, and I'm just going to go ahead and continue to label. And 3 ninths goes right here. I was just able to prove my answer that all 3 of my fractions, of my different fractions, 1/3, 2 6, 3 ninths, are all equal. They all take up at the same space and the same spot on my number line. They are showing equivalent fractions because they are at the same space or spot on my number line. Another way to think about this is that 1/3 and 2 6, when you look at 1/3, it's almost as if they drew a line right there and they just kind of turned it on its side. 2 units, 2 units. It still takes up the same amount of space, but it shows 2 6 now. For 3 ninths, they did the same amount. If I were to move these 3 shaded units all across in one row, they would be equal or equivalent with 2 6 going across this first row. They all take up the same amount of space, or they name the same amount. They're just different fractions. Let's look at the problem set. The directions read, write the missing parts of the fraction. Number 1 shows 1/3 equals blank over 6. Well, I can see that this is broken up into 6 and 2 6 are shaded. So 1/3 equals 2 6. You're going to go ahead and you're going to complete the second one and the third one, all of 2. And then you're also going to be completing number 3 and number 4 by yourselves independently. I will be coming around and checking your work and conferencing with you if needed. When you're ready, go ahead and pause the video to complete these problems. After completing them, resume playing to check your work with mine. Are you ready? Go ahead and pause. Go ahead and check your work with mine. It's okay if your answers for 3 and 4, what you wrote, looks different than mine. However, if your answers are completely different and I haven't been around a conference with you yet, you do need to write down my responses before I come down and conference with you so that we can talk about it. I am going to be looking to make sure that your pictures, when you draw them, your 2 different fractions name the same amount. That's what I'm going to be most concerned about here. Great job in today's lesson. You were able to generate simple equivalent fractions by using visual fraction models and the number line. Go ahead and get ready to do the next step.